Hello everyone, welcome back. This is Engineer Hussein Mosab. So in this video we'll be looking at vector addition in 2D, that is applying the law of the parallelogram. So under the parallelogram law there are certain objectives that we have and we'll look at them. But before we get to it, don't forget to like and subscribe. So since we're applying the parallelogram law and it's in 2D, remember we're only using the x and the y-axis, as other people term them to be the I and the j. Alright, so we have several objectives that we have under the parallelogram law. But our first objective is simply to learn how to find the resultant vector given two vectors. Alright, let's get to it. We'll understand this with an example. Alright, so the example says the screw eye in the figure is subjected to two forces, which is force 1 and force 2. Now we've been asked to determine the magnitude as well as the direction of the resultant force. We've been given the 15 degrees there as well as the 10 degrees there. So how do you go about finding the magnitude of the resultant and its direction using the parallelogram law? So we're going to follow some steps. So let me write the steps here. Step 1, extend the lines. Now these steps I'm giving you are the steps you have to use regardless of what they ask you to find, provided that you are applying the parallelogram law. Alright. Step 1, extend the lines. So I'll extend the lines of the vectors I've been given. So I have F1, I extend F1. It doesn't have to be to scale, just extend the lines. I also extend F2 like that. So I've extended the lines. Step 2, draw parallel lines. Now the parallel lines we're drawing are of F1 and F2. So now the parallel line of F1 that we have here has to pass through F2. So I'm going to draw a parallel line of F1 to F2. So either way you want, you can draw it at that point. If you want, you can draw it at a different point like that. If you want, you can draw it at the top, provided that the one you have drawn is parallel to what? F1. That's the key. So I have drawn my parallel line of F1 touching F2 like this. Then once you draw a parallel line of F1 passing through F2, just have to draw another parallel line of F2 touching F1. So you can draw it here if you want, or there, anywhere, provided that you are comfortable with the line and you can see the shape that will be drawn, because in the end we're drawing a quadrilateral. So I'll draw it at this point. So as you can see, we're having a quadrilateral. I'm having this point here, the point here, point there, and there. So this line here is parallel to this line. This line here is parallel to that line. So this line here that I'm having here is simply equal to 100. So I'll put 100 there. Even on top, I'm having 100. And this line here is simply parallel to the line that I've drawn there. And this line here is simply F2. So my F2 is 150. So even this side, I'm having 150. So that's what I mean when I say draw parallel lines. So we have now that quadrilateral, as you can see. Now the next step is simply just to find the angle in between the two vectors. always do this. Always find the angle in between the two vectors. As we can see, I'm having my f2 there and my f1 there. So I'm looking for the angle in between, which is this angle. Now as you can see, I already have 15 degrees there, and I also have 10 degrees there. And from the looks of things, this is the y-axis and this is the x-axis. So from this point to that point, I am having a 90 degrees. So for me to find the angle in between, theta, I know it's forming a 90 degrees. I'll just have to compute it. So I will say, let's call this theta. So theta plus 10 plus 15 should give me what? 90. So theta plus 10 plus 15, that's 25, is equal to 90. So theta is equal to 90 minus 25. So theta is equal to what? 65 degrees. So I found the value of what? Theta, which is 65 degrees. Alright, now remember what we're having is a quadrilateral. So I'm going to pick the image of the quadrilateral and just draw it somewhere so that we can see it clearly. So we already have the 65, so let me just erase this and draw the quadrilateral. So the quadrilateral can be drawn in any way. You can draw it like that, any way you want. If you want to, if you are an artist to say, you can draw it in an artistic way, whereby you make sure that it looks very, very nice. But since we're just solving, let's just draw a random quadrilateral. So I'll just draw a random quadrilateral so that you see what we have. So we have the angle here, which is 65 degrees. We have the length here, which is what? 150. Even this side is 150. We have 100 and also 100 there. So what we can do is now find the next step. Step 4 is to find all the angles inside the quadrilateral. So you need to understand that the angle you have here will always be equal to the angle you have there, and the angle you have here will always be equal to the angle you have right there. So I'm having 65 here, so which means that even this part here will be what? 65 degrees. And remember, this angle here, let's call it x, will be equal to the angle I'll have where? There, which will also be what? X. Now since this is a quadrilateral, remember the interior angles of a quadrilateral will add up to 360 degrees. Let's not forget that. So let's now solve for x. So let's sum up all the interior angles. So we say x plus 65 plus 65 is equal to 360. So x plus x, that's 2x, plus 65 plus 65, we have 130, and this is equal to 360. So 2x is equal to 360 minus 130. So 2x is equal to 360 minus 130. Yes, that will give you, yes, 230 divided by 2 divided by 2. That cancels with that. X is equal to 115 degrees. So now the value of x is 115. So we have 115 degrees there and 115 degrees there. So we have found all the angles inside the quadrilateral. Now let's focus on the same quadrilateral here. Remember, we're trying to find the magnitude of the resultant. Now, since we have found the fourth step, let us move on to the fifth step. So the fifth step simply states that we need to draw a resultant line. The resultant line will come from what? The center. Now the center is simply this point here. This is the center. You can call it O if you want. So my center is here. So my resultant line will come from the center and it will touch the point of interest. Remember, when we're drawing the parallel lines here like that, you found that when you drew this, that, and that, these lines have to meet at one point, this point here. So this point is our point of interest. Let's call it P. So that P is simply there. So the resultant line will come from the center and it will touch what? Point P. So I'll draw it. Touching point P. And I'll call this the resultant of the vector I'm looking for. And since it's a force vector, it will be F sub R. So we have two shapes now, since I've cut the quadrilateral. Now if you cut the quadrilateral from its diagonal, you will have triangles. So I have triangle A and triangle B. Now once we do that, all we have to do next is to pick one triangle, which is step 6. Pick one triangle and solve for FR, which is a resultant. Now the methods that we use is the sine rule or the cosine rule. In most cases, you have to remember that the cosine rule is mostly used to find the resultant, but that doesn't necessarily mean that the cosine rule always just give you the resultant. It can also give you the angle at a particular point that you're looking for. The sine rule is mostly used for the direction and finding angles, but that doesn't necessarily mean that it's the only thing you can find. You can also find the length of maybe the side that you're looking for. You can also find the components, you can find the resultant using the sine. Same thing with the cosine, you can find the components using the cosine as well as the resultant, even the angles. You just have to know how to go around working with your math techniques. The sine rules and the cosine rules you learned. Alright, so let's pick one triangle and use the sine or the cosine rule to find the first resultant. Alright, so I'll erase this. So let me just get my eraser, increase the capacity, and then delete this. I hope you have written all these steps. These steps are the ones we follow when solving any question that says find the resultant of some given vectors, or even at times you also use it to find the components. Alright, so I'm going to pick one. So I can pick B or A. Either one of the shapes that I would pick to still give me the same value that I want. I'll still get the same answer. So I'm going to pick, let's pick B. So if I pick B, we're having that. This line is not okay. Let me draw it like that. You guys should have better drawings than me, because you have rulers. Unfortunately, I do not have a ruler. Okay, so like that. Alright. So we know this is 100 and this is 150, and this angle here is 115 degrees, and this is our force resultant. Alright, so given two sides, 1, 2, and an angle at the middle here, we can use the cosine rule to find the resultant. So given two sides and an angle at the middle, use cosine to find the resultant. So I'm going to summarize the formula. We know that force resultant is equal to the root of F1 squared plus F2 squared minus 2 times F1 F2 times cos theta. I must just like to put the multiplication sign there because most people make mistakes when punching on their calculators. So force resultant is equal to, if I substitute in with the values, F1 is 100, so 100 squared plus F2 is 150 squared minus 2 times 100 times 150 times cos theta. Remember, theta is the angle at the middle. So I have 115 degrees, like that. So if I punch this on my calculator, I will get 212.5524591. So all my answers will be rounded off to 2 decimal places, but that doesn't necessarily mean that all your answers should be in 2 decimal places. You have to follow the instructions given. For me, I'll just be rounding off to decimal places. So therefore my force resultant is equal to 212.55. Now look at the components of F1 and that of F2. The components are in what? Newtons. So even your resultant has to be in what? Newtons, like that. So that's our force resultant that we found. Alright, so we found the magnitude or the size of our resultant, which is that. The next thing we're supposed to do is to find the direction. Alright, let us find the direction now. So for the direction, I will explain it in a way that I feel like most people can understand. Let's not forget this answer. I hope you have written it down somewhere. Just want to create space. Okay, let's erase this. That's some pure magic. Alright, so going back to our pen. Now, since we're looking for the direction, look at what we have here. Let me just erase the entire thing here. The direction, if you remember, the quadrilateral looks something like this. Let me just draw it roughly like that. So our resultant is there. First resultant. So now be mindful that the direction, take note of this, the direction, which is theta, is always measured from what? The positive x-axis. That is if they haven't specified. Sometimes I would say it's measured clockwise or counterclockwise. So in this case, from the positive x-axis, that is counterclockwise. So it means we're going in that way. But sometimes I would say clockwise, while you have to say go in that direction. So if they say counterclockwise, which is the same as one saying from the positive x-axis, it means that this is our x-axis, as you can see, and this is in the positive side. So from the positive x-axis, it means that from this point going all the way touching the force resultant. So the angle in between here is the direction. But if at all they say that it's measured counterclockwise from the positive x-axis, it means you have to find this angle, where you look for the angle here and then subtract it from what? 360 degrees. But in this case, we're measuring it from the positive x-axis. So there to that point there. Alright, so we want this guy here, theta. So we know that we've been given the angle here, which is what? 15. But theta is a combination of 15 plus the angle here inside the triangle. And this angle, we can call it theta prime. So from the diagram we drew here, we can label theta prime. So this one here is what? Theta prime. And since we've already solved the resultant, if you remember, the resultant was found to be 212.55. So now that we have all these values, we can now solve for what? The direction, which is by first finding what? Theta prime. So we know that the direction is equal to 15 plus theta prime. Now let us look for theta prime. So just give you a random drawing there. We have 115, we have 212.55, we have 150, and we have 100. And we're looking for this angle here, theta. Now, whenever we're looking for the direction, we mostly use the sine rule because it's just quicker. But you can also use the cosine rule, that's if you want. It literally just depends with your math skills. So, in my case, I'll use the sine rule. So, when it comes to the sine rule, you first have to get the sides that are values. So, we know that we have this that points to the length that is given, that we found to be the resultant. So, we're going to get that sine value first. So, we say sine 15 over the length, which is 212, excuse, 0.55, and now this is equal to what you're looking for. So we have this that we're looking for pointing to this guy there. So this will be sine theta over 150. Then all we have to do is to cross multiply. So this will be sine theta times 212.55 is equal to this guy times that guy will be sine 115 times 150. Now since I'm looking for theta, I can go with theta prime there. So I will divide both sides by what? 212.55. Even this side 212.55. So that cancels with that. So I have sine theta prime being equal to sine 115 times 150 divided by 212.55. Now, since we're looking for theta prime, means that theta prime is equal to sine inverse of sine 115 times 150 divided by 212.55. Alright, so if you compute this, you find that theta prime will equal you to 39.76171.425. Now correct to decimal places, this will be 39.76 degrees. Now this is not really the direction. Remember, the direction is 15 plus theta prime. Alright, so we'll just compute that here. Let's erase this. So the direction theta is equal to 15 plus theta prime. So theta is equal to 15 plus the theta prime we had found, which is 39.76 degrees. Therefore, theta is equal to, this will give you about 54.76 degrees. And this is the direction. Therefore, one can write this as the force resultant is equal to, we found 212.55 newtons measured at 54.76 degrees. So this is the magnitude of the resultant and its direction measured from the positive x-axis. So this is how you go about finding the magnitude of the resultant and its direction given two vectors. We are always going to be using these steps. Step 1, extend the lines. Step 2, draw parallel lines. Step 3, find the angle in between. And for quadrilaterals, once you just find the angle in between, then you are safe, because the angle in between here is equivalent to the angle you have there. And once you have this angle and the other angle there, all you have to remember is that this angle and that angle is the same. So you can call it x and the other guy x as well, so that you sum up the interior angles. And remember that a quadrilateral adds up to 360 degrees. So you add up all the interior angles and then equate to 360. You compute, you'll get the angle that is x there, isn't it? Once you find the x, this angle is the angle we use for the cosine. Once you find that angle, all you have to do is to draw the resultant line that will come from the center, that point there, touching the point of interest where the extended lines of the parallel lines had to meet. After that, neglect the cancelled angles. This 65 and the other 65 will no longer be in use. Then you have two shapes, shape A and shape B. Just pick any shape of your choice. You can pick A or B. They will always give you the same answer. You just have to do a lot of drawing. It helps. Yeah, just don't be lazy. Draw a lot of drawings. If you are an artist, you enjoy them. Just do a lot of drawings so you have that shape there. You can put up some values that you see. You see the 100, you see the 150, and then the angle there, and then apply the cosine. Remember, two sides, angle at the middle. You can find the resultant. You punch, you find. Just do a bit of practice, solve many questions, and you get the hang of it. After that, you can always find the direction. Just be careful with the direction. When they say from the positive x-axis, remember I was moving. From is like you have the x-axis there. So from until you touch that resultant line that you have of your force. That's what they mean. But if they say counterclockwise, it has to go in the opposite direction. Be mindful about that. Then once you do that, you also now apply the sine rule to find mostly the angles inside the angle you drew, because it will not always be that the resultant will be at the point where an angle is given. It's in rare cases, so be mindful about that. Then in a nutshell, you can just now write it in this notation. If you want, you can just say, okay, the resultant is this guy and the direction is that one. Either ways, you're fine. Alright, thanks for watching this video on how to find the magnitude and the direction of the resultant vector given two vectors. If you have any queries, you can reach me on WhatsApp on 077 149 5252. Remember, slow progress is better than no progress. Let us strategize to avoid becoming a statistic, and let's try and push for that A+.